Hi, today we're going to look at momentum. By the end of this video, I want you to be able to answer these three questions. First of all, what is momentum? Second, how do you calculate it? And third, how does momentum relate to force? And really, in there as well is going to be, what can we use the idea for? So, what is momentum? Put simply, momentum is the quality of an object that makes it hard to stop. The higher the momentum, the harder an object is to stop. Now we already know quite a lot about this already. So if I'm playing rugby and a big guy runs at me, I'm going to be slightly more worried than if a small guy runs at me. Because I know that the big guy is going to be harder to stop than the small guy. And the reason is, the heavier player, has more momentum than the lighter player. So the first thing to note is momentum is related to mass. Now that mass needs to be in kilograms. I also know, if I'm playing rugby, that a fast player running at me will have a bigger impact and will be harder to stop than a slow player running at me. So that tells me, from my common everyday experience, that velocity is important here as well. We measure velocity in science in meters per second. Now in science we often use equations like this one to help us to record an idea simply and to put numbers to it. But every equation tells a story. Half the trick is remembering what story is being told. So if you can't remember momentum equals mass times velocity, just try and work it out like this. Momentum is the ability of something to be stopped. It's harder to stop objects with more momentum. So if I increase the mass, will it be harder or easier? The mass goes up, the momentum goes up. If I increase the velocity, will it be harder or easier? Velocity goes up, the momentum gets bigger as well. So this equation, don't worry about it, it's just showing you that story. That a big, heavy rugby player moving at a high speed is a lot harder to stop than a tiny little rugby player going slowly. Now there's another equation related to momentum that's very useful. And this is one that car designers use whenever they bring in crumple zones. That's the reason why there are crumple zones in cars. A crumple zone is a part of a car that's designed specifically to crush with an impact. And the reason it crushes is to spread out the time that the momentum is changing. But why should that make a difference? Well, the equation gives us a clue. In this equation, the change in momentum equals the force applied to make that change times the time that has to be applied for. So an object with a lot of momentum will be harder to stop than an object without much. We know that from what we've just learned. But an object, if I want to stop that object, I've got two choices. I can either apply a big heavy force, a big strong force, for a very short period of time, and that will bring it to a halt, or I can extend the time and reduce the force. So a little force can bring an object to a halt, but it will take more time to do it. Again, look at the story of the equation. A big force will take less time to bring an object to a halt. A little force will take more time to reach the same number. So if this number goes up, to reach the same answer here, this number will have to go down, and vice versa. But how does that relate to crumple zones? The purpose of a crumple zone in a car is to extend the time of the collision. And the reason why that's important is, it means that less force is hitting the body of the occupants in one go. And as a result, there's less damage. So as we spread out and make a car impact stretch out a little bit longer, there's less chance of serious damage to the occupants. And a crumple zone is designed to do that, to reduce the damage by increasing the time, to reduce the force by increasing the time. Now I hope you've learnt something today, and I hope that now you'll be able to tell me what momentum is, how we can calculate it, and how it relates to force.